Hello and welcome to Advantech's Talk. I'm your host, Matt Dentino. Today's topic is another in the series all about our digital transformation of the industrial workspace. On today's Talk, we'll be talking about machine condition monitoring. We're going to look at recent trends in the IoT area, what technologies companies are implementing, what parameters they're tracking with that technology, and then exactly how they're collecting and using all that data. I'll be joined today by one of my Advantech colleagues, as well as a condition monitoring expert from Prowave, one of our partners in this space. Together, they're going to help me to unpack all the why, how, and what of condition monitoring, why it's important to the IoT world, how industries can benefit from implementation, and what makes a comprehensive machine condition monitoring solution. To get started, let me introduce you to my two guests today. Mr. Danny Su from Prowave. Danny is manager of their monitoring SBU out of Taiwan and an expert in machine condition monitoring with decades of experience. Also with us today from Advantech is Sen Wu, who is Advantech's product manager for Smart I/O and communication, with more than 16 years of experience in the industrial automation arena. Gentlemen, thank you for being with me today. Welcome, Danny. Before we get into our discussion, can you tell the audience a little bit about your background and give us a kind of a brief introduction to Prowave?
Okay, thank you, Matt. Established in 1989. Prowave have 32 years of experience in vibration analysis, covering various major industrial fields. We were certified by the Ministry of Economy as a technical service agency chain. Each of our equipment diagnostic personnel has ISO 18436 vibration analysis certification. Prowave is also a general agent of US PCB accelerometer. As predictive maintenance is one of the king of the Industrial 4.0. We aim become customers trust the partner in condition monitor system. Or we have set up a remote analysis center and online inspection to enable back-end analysis. Also, we have built industrial certificate online presence on more than 4,000 channels in order to support customers in different industries. We are here to meet customers' testing needs from simple to complex and create a win-win future vision.
Excellent. Thank you for that, Danny. We're looking at this topic today in terms of how it relates to the concept of Industry 4.0 and the intelligent factory. These factories adopting an Industry 4.0 stance should not only strive for manufacturing technology innovation, but they should also focus on machine monitoring, which is an important part of the optimizing the production process. So unlike traditional periodic maintenance or emergency breakdown repair, condition monitoring allows the plant maintenance team to detect and troubleshoot hidden faults in advance. Take a CNC machine, for example. An engineer can perform condition monitoring by collecting signals ranging from temperature and sound and vibration, even energy usage, to predict things like motor or bearing and spindle health of the machine. So when implemented, this type of a routine cuts down on the unexpected machine or parts failure, which in turn cuts into emergency work orders, overtime, the frantic rescheduling of suppliers, or parts for outside expertise bringing people in. Machine outages can then be scheduled and planned which is going to reduce the equipment downtime and increase overall plant productivity while also improving consistent quality of the finished goods. So condition monitoring should be considered a necessity for all of our critical assets and even some of their secondary or ancillary type of equipment in order to more efficiently plan and effectively manage the health and life of plant equipment. That way, we're going to avoid unexpected incidents. Now, that's the scene, that's the backdrop for our conversation today. And we're going to dive back in with the guests. Danny, let me come to you. As you've been working very closely with end users for decades, talk to us about what you see as the main pain points that that a good machine condition monitoring program can address.
Okay, and I will share my experience. Before we jump into customers' pain point, I would like to give you an overview of development of equipment maintenance strategy. As you can see from the slide, the conventional methods we use is breakdown maintenance and in order to create higher value in business. The method has evolved into preventive maintenance, condition monitor, and proactive maintenance. But the factory operator gradually become unsatisfied with the breakdown maintenance and preventive maintenance. Breakdown maintenance means maintenance after breakdown. It can cause production interruption and longer downtime. It may also result in secondary equipment damage from the failures. About preventative maintenance, it involves regular or scheduled inspection and repair. Even when the equipment is functioning, that is, sometimes equipment may not need to be checked as often as planned. The unnecessary shutdown will interrupt the productive. I think the disadvantage mentioned above lead of the following pain point is equipment maintenance. One, unexpected machine failure result in loss in manufacturing process. And two, unable to predict time, coordinate maintenance staff and delivery necessary materials. And three, waste of resource and caused by unnecessary maintenance. And the last point, unable to measure personal risk.
And I've also seen inspection induced failures at plants that use highly preventive types of routines to add to what you were just talking about, Danny. You know, things like dirt kicked into the oil reservoir or a rag dropped into an intake and not discovered until they go to start the equipment back up. Those are all excellent reasons to promote and implement a condition-based monitoring program, along with being able to better assess the real-time health. So, Danny, can you explain more about why, from your experience, why a condition-based monitoring program is so important?
Sure, no problem. This approach enables operators and technicians to remotely monitor the machine performance. The condition data will be collected. The condition monitoring software interprets the data and sends an alarm whenever a change is detected in machine health. Therefore, condition monitor is used to detect problem before unplanned breakdown and schedule repair, responding to the problem. Also, condition monitoring can easily locate the damage in machinery and identify the potential risk.
Against that background, then, Danny, what does a condition monitoring program look like? If you were starting up a new program, what technologies would you use, and how would it work?
Okay, we adjust work around monitoring in some cases. However, in some situations, equipment is hard to reach or in a hazardous environment. So we need online condition monitoring, which continuously check the state of a system, a machine, or a process, and generate data in real time. Take a Prowave online wire condition monitoring solution. As an example, an ICP vibration accelerometer is installed on the device to measure the vibration of the machine, which is converted into a voltage and passed through a physical signal line. The voltage value is first transferred to the DIQ. The DIQ is signal acquisition card for equipment, converted into a digital signal and then transferred to the system host via network or optical cable.
Excellent. Excellent information. Thank you for laying that out for us. Let me now bring in my Advantech colleague, Sen Wu, for this next question. Sen, you've had over 16 years of experience in the automation industry. And as Advantech's Smart IO and Communications product manager, what can you tell us about Advantech's role in providing solutions to help drive this trend towards machine condition monitoring in smart factories all around the world?
Thank you, Matt. Machine condition monitoring is the process of monitoring a parameter of condition in machinery, vibration, temperature, etc., to identify a significant change with indicative of a developing fault. DAQ as bridge to accurately acquire the characteristic signals, sound, vibration, and so on from operating machines, then turning into the data then can be interpreted by computer. By monitoring this interpreted data, Advantech believes that DAQ can contribute to smart factories in terms of reducing the production of defects through anomaly detection and improving efficiency through predictive maintenance, as known as machine condition monitoring. As a leading supplier of data acquisition products worldwide, Advantech has offered a wide range of I/O devices with various interfaces and solutions from signal condition modules, plug-in PCIe cards, portable USB modules, DAQ embedded computers, and the modular DAQ system, as well as the Navi SDK software development package. Advantech's DAQ products are designed for all kinds of industrial automation applications, from machine automation, measurement and control, to machine condition monitoring.
So it sounds to me like the Advantech products cover everything from the shop floor to the top floor with all the interconnectivity and software in between. I'm going to jump back over to Danny here for a second. Danny, let me come back to you for a second and ask you this next question. I've been keeping an eye on new infrastructure technologies, and with the move towards 5G, as well as a lot of new wireless technologies, can you tell us what do you think technologies that are available today and will be coming available in the future, do you think that they'll actually be driving this adoption of condition monitoring, whether it's walk around or online? Where do you see that going?
I would like to introduce Laura Wayne first, and the latest technology in recent years. LoRaWAN is a low-power wide area networking, the LPWAN protocol designed to wirelessly connect end node to the internet. With its small power contribution, the battery life of a LoRaWAN device can last up to 10 years. More important, LoRaWAN device transmit a signal over a long distance and provide deep indoor coverage. Also, LoRaWAN use AES 128 encryption to secure point-to-point data transmission. Last but not least, it effectively reduces the cost due to no wiring and cabling. Now, let's take a look at how we use LoRaWAN device in online wireless monitoring system. A wireless instrument is installed on the LoRaWAN sensor to measure the vibration value of the machine, and the vibration will be converted into digital signal directly in the instrument. The signal is then sent to the gateway through wireless transmission, and the gateway is transmitted to the system host through the network or optical fiber.
Excellent. Yeah, thank you. Thank you very much. Since Danny just mentioned that wireless LoRaWAN sensor being used for machine condition monitoring, then can I ask you to share more about Advantech's wireless solutions?
Sure. Wireless communication is crucial for IoT data collection. In addition to widely adapted wireless Ethernet technology such as Wi-Fi mesh and 4G, LTE, 5G cellular networks for high-speed data acquisition application. In recent years, low-power wide area networks, as known as LPWAN, suitable for long-distance transmission applications, such as LoRa and NB-IoT, have also become popular in remote facility monitoring applications. In this regard, Advantech provides a wide variety of sensing and communication devices supporting major wireless communication and CUDA integration technologies. Among the devices, WISE-2000 series is a wireless and sensor all-in-one solution, which is targeting in energy management, equipment maintenance applications. Advantech LoRaWAN vibration sensors join with Prowave's condition monitoring software, creating the GN LoRa wireless monitoring solution. It has been used in vibration monitoring and diagnostic analysis of machines and equipment. The wireless monitoring solution analyzes vibration characteristics to enable early warning and prevent machines from unannounced downtime. It provides large amount of labeled data for IoT or AI use.
Excellent. Excellent information. So, Sen, do you have any specific industrial application examples where an end user is implementing the solution?
Yes, here is an application about condition monitoring in paper mills. Up till now, the paper mill used the handheld devices to monitor the status of the motors with regular inspections carried out to check everything works as it should. However, manual inspections are time-consuming and dangerous, and the issues are often difficult to diagnose. What the paper mill needed was an online monitoring system to perform on-site inspections, which would also reduce labor costs and risks to staff. We cooperated with Prowave and provided a total solution, including Advantech LoRaWAN vibration sensor, gateway, and Prowave's GN LoRa system. The vibration sensors attached to the bearing housings of the motors and pulleys connected then to the paper machines. This would transmit the rotational speeds and acceleration eigenvalues through the LoRaWAN wireless. Networks to the WISE6610 gateway, the data can be read and analyzed by GN LoRa system, and the results were further sent to customer SCADA system.
It's a great real-world application example. I have to tell you that years ago, I actually spent a lot of time collecting vibration data in paper mills here in the Midwest in the United States. And I can tell you from experience that some of those motors and bearing housings can be hard to get to and even intimidating when paper's flying by your face at 3,000 feet per minute. Not to mention when you have permanently mounted sensors, you get a great consistency and repeatability in the data, which is important for the analysis. There's no mistake where the sensor needed to be placed was placed in the wrong place, or you're not worried about getting the data from the same spot in the same orientation every time. It's consistent connection to the machine. So I've actually lived that example that you just provided and can attest to the benefits of online monitoring for that type of an application. And with that, we've come to the end of today's InnoTalk program. During our program today, we heard from experts how machine condition monitoring can help prolong the life of critical plant assets, reduce unscheduled outages, increase prime production time, and improved yield. We talked about trends toward wireless solutions that are not only intelligent, low power, and provide excellent repeatability, but are secure and suitable for use in hazardous areas where you wouldn't want to send people. And we pulled it all together with a great example of this machine condition monitoring technology being implemented currently in a paper mill. All in all, it's been a great conversation, and I'm happy to have been able to spend time with my two guests unpacking all of this for you. From Prowave, Mr. Danny Tew. Thank you again, Danny, for your insights and your expertise.
You're welcome.
And from Advantech, Sen Wu, I greatly appreciate your insights and your experience. Thank you for being with us today.
Thank you, Matt.
And to our audience, I want to thank you for joining this Advantech InnoTalk. As always, if you have any questions or would like more information about anything that you've heard here today, you can reach out to us at www.advantech.com. You can also reach us at iiot.tech@advantech.com. We'll always make the slides from today's conversation available to you for download, so please take advantage of that, as well as the opportunity to subscribe to Advantech's InnoTalk for more videos. We look forward to hearing from you and answering any questions that today's discussion might have stirred up. For Advantech, I'm Matt Dentino, and I hope to see you again right here on our next InnoTalk. Until then, so long.